Hello everyone, welcome to the quantum computing series, which we are calling it as thinking beyond bits. Right, today we are on session 4. I think I will keep it very short and then try to stick around to one of the interesting topic, which is very fundamental, understanding between bit versus qubit, right? And then we will take one small step at a time, right? When I meant that, we will try to simplify as much as possible so that everybody will be able to relate and then talk about it, right? So let us start with something very important, which means if you understand this basic idea, then the difference between bit versus qubit is very clear. And the important takeaway from this session or video would be why quantum computing exists at all. If you understand this, so then our perspective changes, right, on every aspect. How to build it, how to code it, yes, that's a different thing. We will discuss it a little later. But why it is fundamentally different from everything we have used so far is what we need to understand. And this is not from a technical aspect, right? Let us stay conceptual for this point of time. And then if you stay with me till the end, it becomes very clear, and then the confusion around quantum computing will reduce significantly, right? So now, what is a bit, right? Let us start with something familiar, which is like a classic computing kind of a thing, right? So I have explained already, your phone, your laptop, server, supercomputer, everything works using bits. When I meant bit, it can be either 0 or 1, right? Now on the right side I have given you what is qubit. That's okay for now. So just see it and then reflect on it for a couple of seconds. We will understand it, what it is in the next couple of slides, right? So now if you see it, so I was all around telling you that the switches analogy, right? A switch can only have two states. One is turning on, turning off. But yeah, there is no in between sort of a thing, right? Yeah, on a lighter note, if the switch is not working, so then that's a different aspect. You can just put it in between, but there is no such state that exists. But as of now, if we speak at a discrete this thing, right? At any moment, switch can be either turned off or turned on, right? These are the only things. Now imagine, I have given some example here. You have thousands and thousands of switches, or millions of switches, billions of switches even. So then we will understand what it is in the next couple of slides, right? So this is very important. Once you just reflect on this image, this visual, so then it is very clear. Based on this, I just wanted to tell there is a limitation. There is a limitation. Understanding that limitation is important. But having said that, bits are very important when you have clear instructions, when there are logical sequence of steps that are lined up, and when there are any repetitive tasks. With this, I will just get on to the next slide. So if you see it here, bits, and then for now here there is an intermediate state, and then you have the final state. So this is how you should read it. But now when the problem arises, when the number of possibilities become more, the systems become highly interconnected. See, the interconnection here, if you see it, and then when you are searching for the best among them, is this the best one? Is this the best? Is this the best? You have to compare. Then the permutations and combinations are becoming more, right? So this is where the classic computer still must exist, because you wanted to choose one combination, you wanted to evaluate it, you wanted to move to the next. So these are the three steps. Simply, when it comes to classic computing, it exists, right? So you choose the first model, or you choose the first option that you have, evaluate it, go to the next, then you compare it, right? Even if at a very high speed, but this one at a time exploration still exists, right? So this becomes the bottleneck at some point of time. So this is not a flaw. This is not a flaw. If you understand, this is what I told. So this is for those kind of use cases, this is exactly working. This is a design reality if you just think it that way, right? So now let us slowly enter into the qubit concept, right? Just reflect on this slide. So slowly we are just entering into the qubit concept. So I am not talking, see, right, you have to understand this. Qubit is not a better bit, right? So let us call it as an information unit at this point of time. Not only information unit, but different kind of an information unit. Unlike a bit, a qubit is not restricted to only 0 or 1. Understand this. Qubit is not restricted to 0 or 1. It can exist in combination of possibilities, right? It can exist in combination of possibilities until it is measured. Now if you see it, there is a coin here. A coin has two faces. Imagine that this is on a table. So it can only show one face at a time, right? Either heads or tails, that's it. So it is either heads or tails. That is like a bit. This is a bit, right? Either 0 or 1, head or tails. But imagine you spin that coin in the air now. It is in the air. It is not clearly heads. It is not clearly tails. Now what does this mean? When it touches the ground, when it touches the table, it has the potential to become either a tail or a head, right? So that spinning state is similar to qubit. Clear? When it is on the air, it has got possibilities either to become a head or a tail. This state, this potential state, this potential word is important. This potential state either to become a head or a tail is a qubit, right? So that spinning state is similar to qubit. The moment you catch the coin and look at it, it becomes a heads or a tail, right? It is a heads or a tail now, right? So that moment is called measurement. Now you are measuring it. So a qubit is not giving you multiple answers. When you catch the coin, you only have one answer. But when it is in the air, the possibilities are different, right? It can be a head or a tail. So it is allowing multiple possibilities to exist before you observe it, right? Before you catch it. Once you catch it, you only have one possibility. Very clear, right? So now let us get on to the next slide and see very, very important, very, very dear to me, because I was just thinking with my interest in philosophy and then the Vedic context, etc., where I just do my academic research out of interest. I was just recalling this sloka, right? This sloka. I will just come to that in a bit. But this is a busy slide, I understand. But let us go one by one. If you see on the left side, right? So let us pause for a bit. Let us pause the technology for a moment and look at the idea from the human and philosophical angle, right? And then try to draw parallels to the quantum computing. In an Indian context, in Indian thought, especially when it is reflected in the Upanishads and the Vedantic philosophy, this is a recurring idea. There is a recurring idea, right? So reality exists in potential. Reality exists in potential, not just in fixed form. This is important. Reality exists in potential even before we observe or even before we experience, not in a fixed form. Things do not become one thing until they are experienced. Three things, right? I'm just telling, until they are experienced, until they are observed or expressed. Before these three things, even before these three things, reality exists. But when we observe, so then they are becoming a reality to us. When we express, so that becomes a reality to somebody else. When we experience, that is becoming a reality to us, right? So now this is not physics. This is just a way of understanding the nature and our existence, right? Now let us look at it. I have given three different forms here. If you think you are an individual, you are an individual, or I'm an individual. Now, but at the same time, me being an individual, also I am a son or a daughter. I'm a brother or a sister. Individual can be a father or a mother. Individual can be an employee, citizen, friend, right? So now here is the key question. You are not all of them at once in action, right? You are not all of them once in action. But now the important question that you need to reflect at this moment is, which one are you right now? Which one are you right now? You are not all of them at once in action, but all of them exist as a potential roles within you. Agreed or not? 100% agreed, right? So I am a son, I am a brother, I am a father, I am an employee, I am a citizen, I am a friend. But which one are you at the moment matters, right? So when you are at home, you are a parent or a family member. When you are at work, you act as an employee. When you are with friends, you act differently as a friend, right? So the key insight here is that until a situation arises, until that context arises, all these roles exist within you are just possibilities. The moment a situation arises or demands one role, you collapse into that role. You become that role. So this is a very powerful analogy if you reflect. So I request you to go back few moments and then pause the video, reflect, listen it to for 2 times, then it becomes very clear. A qubit behaves in the same way. Isn't it? This is a very powerful analogy. Qubit behaves in the same way. Just like you are, there are multiple possibilities that exist. A specific outcome appears when you are unobserved or when it is required. Clear? So now, just like you are not confused. When you are a son, you play that role. When you are a brother, you play that role. When you are a father, you play that role. You are not confused between your roles. You are not random also. You don't act rand, right? When your daughter calls, when my daughter calls me, so I don't act like an employee, right? I'm not confused between my roles. I play them as and when they need it, when the situation arises, when the context arises, contextually, right? And I am not multiple people. Clear? So just like an individual, they are not confused when they are playing roles. They are not playing them randomly. They are not multiple people. A qubit is also not confused either. It is simply responding to the context. This is very important thing, right? Clear? With this, now there are 3-4 different things which I will explain, right? Which are very, very interesting. So Indian philosophy often speaks about specific words. I will try to give you closest English words for them, right? Potentiality versus manifestation. Potentiality versus manifestation. So here there are 6 potentialities, but you will an individual can manifest them as and when the situation arises. Now unmanifest to manifest. So when you are an individual, nothing is manifested yet. But when you are a son within you is manifested. Brother within you is manifested. Observer versus experience. Similarly, when you are an individual, yes, you are just observing, but you are experiencing something. All these things without using heavy words, or let us keep the idea simple. That is the core intent of this series, right? What is not yet observed by an individual exists as a possibility, not absence, right? Simple. So I have never been to UK. That doesn't mean that UK never existed. I don't know. I have never experienced it. I have never been there, right? That doesn't mean that UK is never there. UK still exists. But in my experience, because I haven't been there, so I haven't experienced it, so I may feel that it is not there, but potentially it is already there. Now quantum computing uses this same principle technically, while philosophy explored it conceptually centuries ago. Not even conceptually, I can go even deeper and then explain it, how they have visualized it, that such a deeper thought. But for now, in this video context, I will try to restrict myself, and then whenever time permits, I will get onto the deeper aspects as well. Now I don't want to bring conflicting things here, right? So this doesn't mean that these thoughts predicted or some quantum physics, etc. Now science comes when we are trying to get some sort of empirical value to it, and then when you will be able to justify, measure them, etc., etc., right? So it simply shows that the thought process still existed. Human thought is very, very powerful and has long explored deep questions of reality. This is what I wanted to convey through this slide as a takeaway, right? But as a modern scientist, as an academic researcher, I still try to find new ways to formalize them. This is more important, while both are important. I'm just trying to draw parallels so that you understand. Quantum computing is not against logic, right? It is not against logic. Logic is still needed. It is not even breaking reality. No, it's not about that. It is simply working closer to how nature behaves. You are just trying to understand when the potential multiple possibilities, and then so that the complex things become very, very simple. So now let us remind, science and philosophy are can go together, right? They are not different worlds. They can go together when rightly understood. Try to understand in different ways, right? But the truth is the same, right? This is what it is. Now transition back to the technology. So slowly, so bits have got fixed roles. Qubits are potential roles. Now if you understand this is the sloka that I just try to recall. So I just quickly flashed it here. It says Isa Vasyam idam sarvam yat kincha jagatyam jagat, right? Which means that literally everything in this universe exists by a deeper reality, right? And even before it appears or takes a specific form, right? Now if you observe here, so only visible exists, 0 and 1, this existed. But if you see it here by a deeper reality, even before it takes a specific form. So imagine, this is the sloka that reminds us, reality is richer than the immediately that is visible. Immediately that is visible only has got specific form. But if you see the universe, reality is very, very richer. It has got many different forms. Reality settles into a definitive form when the outcome is observed. That's the quantum computing. But if you see, there are much more deeper things to it. This is what I wanted you to reflect a bit and then try to understand. See how richer the thought is, right? I have many slokas written in my notes. Probably when time comes I will just try to draw parallels, but I'm trying to keep simple things here, right? So now if you go to the next one, there are 3 things that I have written here: optimization, simulation, probability heavy problems, right? This is what it is. So optimization, simulation, probability heavy problems. So now with bits you explore one path at a time. Clear? You are exploring one path and then you are exploring the second path. You compare them both, so then you choose one, right? But with qubits, so you have many possibilities, multiple possibilities together. You are not restricting, you are not limiting yourselves. So when for different use cases this works better. So when you are optimizing, when you are a simulation scenario, when there are probability heavy problems. So the objective of this slide is to just give you this vocabulary, but eventually in next videos I will try to explain them and then double click on them, right? For a bit deeper understanding. Now reflect on it for a moment. This is a very, very important, right? So understanding is important, but clearing misunderstanding is very important. Understand this, right? So this is the thing. When I meant qubit, it doesn't mean it gives me infinite answers. No. When it takes a final form, it is only giving me one answer. It is not giving me random answers. No, it's not that. It is giving me that specific answer when it is dealt with a specific approach or a process, which we will see little later. It is not guessing or gambling. No, you are doing with a specific scientific method, and you are going that way, right? So useful answers more likely, unuseful answers cancel out. Just reflect on it a bit. No, this is not what we are doing basically, right? You are talking about engineering, a scientific approach, not randomness. So this is what I just want you to draw or take away from this slide, right? Now finally you understand this. Qubits are fragile, hard to control, expensive to maintain, right? So which means this is not for every use case. For every use case you will not use it. So imagine I have told you already, you have a camera, you have a microscope. You don't use them for the both, right? For clicking pictures or images or making memories, you do that with a camera. But if you wanted to do some deeper analysis, or if you wanted to do some specific use cases, then you microscope is for a different thing. You know it, right? This is what it is. So now bits are stable, they are very reliable, and for daily computing it works. So now the objective of this slide is that you need to take away both works together, right? So this is what is the thing. So your simulations, experiments, models, decisions, this should be the loose sequence, but when we go deeper I will just explain them, right? So now let us close this video with a deeper thought, right? Let us close this video with a deeper thought. Reflect on it till the next video comes, so that it becomes very easy for you. The difference between bit and a qubit is small in appearance, is very small in appearance and thin, but massive in implication. Understand the words what I wrote. Very small. If you see, it is very simple, but massive implication it has got. This is represented, explored, addressed, right? How problems are represented, how are you framing them, how are you looking at them matters. The approach matters. Now how the possibilities are explored. When imagine the coin, when in the air, you have multiple possibilities. That is how you are exploring them. And then how limits of computing are addressed. You are no more linear, you are no more doing things in sequence, you are thinking all possibilities in one go, right? That's the idea. Imagine the richness, imagine the possibilities. So that is where the process is, right? So now working together is what is important. With this I will halt here for this video, and then with the next series of videos we will extend and then discuss very interesting topics, taking one step at a time. So thank you very much. If you wanted to connect beyond this lecture, so this is my LinkedIn ID, you can flash it, and then my messages are open. If you have any suggestions, improvements that needs to be made, or any questions, you are free to put it there, either in the comments here as well. But with a standard disclaimer, I may not be able to immediately reply them, but when I reply with relevance, right? Thank you very much for watching this, and then we will meet very soon in the next video. Thank you again.